All right, so complex numbers, we've been working with imaginary numbers. Now we're going to be adding the real numbers to them as well. So a complex number is a combination of both a real and imaginary number. So if we look at 5 plus 2i, because 5 is a real number, 2i is a pure imaginary number, they are not like terms, so we can't really combine them other than with an addition or subtraction sign. So this is what the type of expression is what we call a complex number. And so we write these in the form of a plus bi, where again, a and b are both real numbers, and of course our I is our imaginary expression. So anytime we're dealing with complex numbers, we want to split it into this. Okay? That's going to be our
standard form.
That's our standard form for complex numbers, right? A real number plus or minus our imaginary piece. So with that in mind, we can start doing operations with our complex numbers. So number one, we have negative 11 plus 3i plus 9 plus 2i. So the way this works, we're just going to be combining our like terms. Whenever we have addition, we can actually just kind of ignore our parentheses. So you can erase them if you want. And then we just combine our like terms. So we have a negative 11 and a positive 9. So what's negative 11 plus 9 give us? Negative 2. And we combine our imaginary parts. So we have 3i plus 2i.
5i.
It's a 5i. There we go. We now have our new complex number.
Wait, that's the answer?
That's the answer.
So it's just combining like terms.
When you're adding, yes. So number 2, we have 4 plus I plus 7 minus 5i. What is our answer going to be?
12 minus 1.
12.
Close.
11.
11.
Nice. Yes, so combine your 4 and your 7, gets you 11. I minus 5i gets you negative 4i. Now when we have subtraction, we have 7 minus 2i minus 2 plus 6i. We now are subtracting this entire piece, so we can go ahead and distribute if you want to. And then combine your like terms. So I feel like if you distribute first, you're most likely or less likely to make a mistake. So then we have 7 minus 2 gets us 5, and a negative 2i minus a 6i, both negative. So we combine them, become more negative, get negative 8i. And then our last one, number 4. So again, first thing we want to do is just distribute our negative to everything on the inside. So we have a 6i minus 14 plus an I plus 5 minus 3i. No longer have any parentheses, so we just want to combine our like terms. So again, start with your real. We have a negative 14 plus 5. It's going to get us negative 9. And then combine your imaginary parts. We have 6i plus I minus 3i. It's going to get us 4i. Okay? So that is our adding and subtracting complex numbers. So the next step is multiplying complex numbers. So multiplying complex numbers is going to make this a little bit more difficult. So recall your powers of I from the previous page on your notes. So those powers of I, where I equals square root of -1, I squared equals -1, I cubed equals -I, and I to the fourth just equals 1. So with that, we can start simplifying these, making it easier. So we have 2I times 8 minus 3I. So in this case, we've got 2I. We need to distribute it to everything on the inside. So 2I times 8, 2I times -3I. So 2I times 8, 16I. And 2I times -3I, 6I squared. And then just like what I said, I squared, again, is equivalent to -1. So we can mark out the I squared and replace it with -1. So essentially we have -6 times a -1.
That's positive.
So that's going to give us a +6. And then we also have that positive 16I. So we can add 16I behind it. And there's our answer. So number 6. We have -I times 2 plus 10. So again, same concept. We want to distribute that -I to everything on the inside. So -I times -2 gives us a positive 2I. And then -I times 10I, -10I squared.
And then I squared is equal to -1.
I squared is equal to -1. And because those two are multiplying, we can really just mark out that I squared and change the sign of that 10. So it becomes -10 or positive 10. So then we get 10 plus 2I, because again, we want to keep it in that standard form for complex. Your real, then plus your imaginary. Okay. Number 7, we got 7 plus I. Times 4 minus I. So in this case, we have a binomial times a binomial. So we have to then boil it out. So we got 7 times 4. 28. 7 times -I, -7I. And I times 4 gives us a positive 4I. And I times a -I gives us -I squared. So then our next step is combine our like terms. And before we do that, we can replace our I squared again with a -1. Now, because there's no number there, we actually do want to put our 1 down and change that sign. Okay. So we have 28 plus 1, and get us a 29. -7I plus 4I is going to then get us a -3I. Okay. Any questions on this? You guys want to do 8, 9, or 10? 10.
Yes.
10, 1 plus 7. Okay, so the first thing we want to do is we have multiplication happening between these two, and we have a negative, so we need to distribute that negative. So let's FOIL out these first two binomials. So 1 times 9, 9. 1 times 3i,
3i.
we have 7i times 9.
63i.
And 7i times 3i.
21. Negative. No, is it -21? Wait, I times that is I squared.
You're skipping that. Yep. So it will become a -25.
I'm right,
Just
I'm right.
you're jumping. So then negative times our inside, so we get -4 and minus 2i. Just kidding, you're exactly right. Mark out your I squared. Becomes a -21. So then let's combine our like terms. So again, start with a real. We have a 9, a -21, and that -4. So let's combine our negatives together. -21 minus 4 is going to get us a -25 plus our 9. -16. And then we have our i's. So let's mark out what we used. We've got a 3i, a 63i, and a -2i. 64. So 66i minus 2i is that 64i. And there we go. So there's our multiplying, adding, subtracting our i's. Now, whenever we're dealing with complex numbers, we can also eliminate our imaginary part. And the way we do that is with our complex conjugates. So two complex numbers in the form of a plus bi and a minus bi can be called complex conjugates. So the product of the two conjugates is always a real number. And because of this, I'm going to be able to do some stuff with it here in a second. So let's look at this first one. We have 8 plus I times 8 minus I. So when we FOIL this out, 8 times 8 is a 64. Then we have 8 times a negative I, negative 8i. And then I times 8 gives us a positive 8i. And then I times -1 is a negative I squared. Now, because we had a positive and a negative I, when we FOIL it out, we get a positive negative 8i. So those two things are opposites of each other out, and they cancel each other out.
So 64 minus I squared.
And I squared is equal to
-1.
-1.
And then those two become a positive 1. So it's 64 plus 1, which is 65.
And that's exactly how we get rid of our imaginary parts. Okay. So again, this happens when your values are the same, but we have a positive and a negative in between. So we have an 8 in both cases and an I, but one's a negative I, one's a positive I. Now again, because I represents the square root of -1, we can't have it in the denominator. If we had radicals in the denominator, we can't do that. So we've already simplified that, but now we're going to be dealing with i's in the denominator. So the way we get rid of i's in our denominator of fractions is quite simple. We're going to multiply essentially by 1. So in this case, we have 10 over 2i. So in order to get rid of the I in the denominator, we want to multiply by I over I. I divided by I. So again, any number divided by itself is 1. So we're essentially multiplying by 1. And by doing that, we're going to be able to eliminate the I in the denominator. So whenever you multiply fractions, again, multiply across. So we have 10 times I.
10i.
It's just 10i. And we have 2i times I.
Negative.
2i squared. And then mark it out, get that negative. So we can simplify this fraction, 10i divided by -2.
-5.
-5.
I.
There we go.
That's the answer.
That's the answer. So we can simplify and eliminate our i's in the denominator by multiplying by I over I. So let's do another one of those. 14. 4 over -9. So again, to eliminate the I in the denominator,
10 multiplied times I.
multiply by I over I.
10 will be 4i over 9i, or -9i squared. And negative, and I cancel it out, it gets -1, and -9 times -1 is +9. Am I getting there?
Mhm.
Yeah. And then 4i over 9.
Perfect.
It's not-
That is enough.
not kidding.
Okay.
But you're also not paying attention. So you just do that for all of them? But what about if there's one like 15? You just subtract first and then go ahead and do it?
So let's look at 15. So we got 28 minus 8i over 4. So in this case, we still want to multiply by I over I. Except now we have that binomial on top. So we got two terms. So we're going to have to just distribute our I both pieces. So 28 I. And we have negative 8 times I gets us negative 8i squared over 4i times I gets us 4i squared.
And then you subtract. Or
So
wait,
again, what do we do with our I
so
squareds?
that'd be positive 8. So 28 plus 8 over negative 4. And then 28 plus 8 is 36. Am I getting there? All right. 8 plus 8. And that's
But we can't add these because of that I, right? So remember, it's a complex number because we have that imaginary part and that real part.
Oh.
So in this case, we can still simplify, but we can't combine these two. So 8 divided by negative 4 gets us negative 2. And then 28i divided by negative 4 gets us negative 7. So there's our answer. So anytime you have that binomial, again, you're just going to distribute. We're still going to have an I and a real number. So we have a complex number now on top, but we still just eliminate that I in the denominator.
What about 19?
Let's look at let's look at 17 before we do that. So 17. Now we have a binomial in the bottom, or a complex number in the bottom. So here's where that conjugate is going to come into play. We can't just multiply by I over I anymore, because if we do, that gets rid of this I, but then this becomes a 5I. And then you just have a never-ending process of having an I switching places. So in order to get rid of the I in the denominator, we now have to multiply by the conjugate. So 5 plus I in order to get rid of those I's.
So then there'll be negative 10i
Negative 10
over
and
5 times 5. That's 25.
so FOIL across the bottom, 5 times 5 equals 25. 5 times I, so that 5I. Negative I times 5,
You got a full
gotta FOIL it. At least for this first one. Because then you're gonna see a pattern. So then negative I times I gets you negative I squared. So again, that positive 5I, negative 5I, those two things cancel out. So that's why I was saying at first, make sure to FOIL it. Because those middle terms cancel out, you're really just multiplying that first term, that 5 times 5, and your last terms together, whenever you multiply by that conjugate.
So whenever there's like two binomials, you always fool them.
You gotta FOIL it.
So 18 we fool it.
You're gonna have to FOIL it.
And then 19 we fool like both.
Yep.
And then 20 we fool both.
Then our I squared again, we can replace with a 1, change the sign. So we're gonna get 26 in our denominator and a negative 10 minus 2I. And again, we can still simplify that. 10 and 26 can both be divided by 2. That's gonna get us negative 5 over 13 minus 2I over 26, again, both divisible by 2. 1 over 13 I.
I might mess up on this part. On the homework.
Okay. So again, you can think of it, you can just split that fraction and simplify it.
So this part is basically full one. So I got your answer.
So you want to do another one?
Yes, no, maybe.
Which one?
Let's do.
20? So we got 1 plus 8 over 2 minus 4. So what are we going to multiply by?
2 minus 4i, or 2 plus 4i.
2 plus 4. Alright, we need to multiply by the opposite.
You gotta switch the sign.
You gotta switch the sign. Otherwise, you're still gonna have i's in the denominator.
And then you gotta fold it.
So we gotta FOIL it. So FOIL at the top, 1 times 2,
2,
1 times 4i,
4i,
8i times 2,
69,
and 8i times 4i,
32i squared.
32i squared. Divided by, FOIL the bottom.
2 is 4, and then 2 times 4, am I right? 64i, that's 8i, and then negative 4, negative 8i, and then 8 plus 8i, right?
4 times 4 is
Oh, 69 squared.
16 squared.
Those cancel out.
Middle ones cancel out. 4 minus 16.
So
or
if we do
positive
that-
16.
So that's gonna change our signs, positive 16, and this becomes a negative 32 on the top.
But up there, them two don't cancel out in the middle, you have to.
So we're still gonna have i's on the top. So we have a 2 minus 32,
30.
30, and it's negative. And then we have 4i plus 16i gets us,
20i squared. But in reality, it'll be negative.
Nope.
Right? Wait, I and I, doesn't it?
but we're not multiplying, we're just combining.
Oh.
So the i's just stay i's. And then our denominator, 4 plus 16, 20. And then we can divide all of those by 10. Essentially just mark out your zeros.
I thought you divide by 20.
Really good in that last one. So we get negative 3 halves plus 20 divided by 20 leaves you with
I.
1 i.
Does it matter if you put I or 1 right there, or do you want to put I?
Well, you need an I. You can put a 1 in front of it if you want. So there is our answer.
Every time I come to class, I get a headache. Big brain.
Using your brain.
Not one class. I know.